Now let's just see some of the examples that are related with the trigonometric ratio. So the very first example states that given tan A is nothing but 4/3, find other trigonometric ratios of the angle A. So first of all, let us suppose if I'll draw a right triangle first. So let us suppose if this is nothing but a right triangle, and since we are focusing on the angle A, so this is my angle A. Let us suppose if I'm taking this one, and this is angle B. Let us suppose this is 90 and this is nothing but C. So it says that tan of A is nothing but 4/3. Tan of A is nothing but 4/3, and we all remember a relationship in between all the lengths of this particular right triangle, that we have tan of A as nothing but a relationship which resembles the perpendicular and the base, that is P by B. P by B actually resembles the tan of A. So P means perpendicular and base means 3. So as you can see, P is perpendicular, base B is nothing but B. So we can see over here that perpendicular is actually 4 and the base is actually 3. So let us suppose if I am taking my perpendicular and base as nothing but 4K and 3K. But before that, let us suppose if I'll write it over here, since this is my perpendicular, this is BC, and this is nothing but base which resembles AB. So let if BC we are taking as nothing but is equal to 4K, and AB we are taking as nothing but is equal to 3K. Let if we are taking these as nothing but 4K and 3K because they are in the ratio of 4/3, means 4:3. So we can take them as nothing but BC is equal to 4K and AB is nothing but is equal to 3K. So since if the perpendicular over here is given into the formation of 4K, and if this base is given as into the formation of 3K, then obviously we can find out this hypotenuse using the Pythagoras theorem. So let us suppose we are saying by the Pythagoras theorem, we know about a fact that the hypotenuse square is nothing but is equal to the sum of the square of the other two sides, means perpendicular square plus base square. So let us suppose if I'm just applying this particular relationship onto this particular right triangle, then we can write AC square is nothing but is equal to AB square plus of BC square. Let's just plug in all the values over here. AC square is nothing but is equal to this would be nothing but 3K whole square plus of 4K whole square, and hence this is nothing but 9K square plus 16K square, and this would be nothing but 25K square. So as you can see, we have AC square as nothing but 25K square. We can write it as nothing but 5K whole square. So if I'll compare both of the values, I will get the answer as AC is nothing but 5K. So actually AC, that is hypotenuse that we are getting, is nothing but 5K. Now we know about all the side lengths of this particular right triangle, then we can able to find out the other trigonometric ratios. So let's just start finding out the other trigonometric ratios. So let us suppose if I am starting with sine of A. So since the sine of A is nothing but perpendicular by hypotenuse, so we can write it as nothing but BC divided by AC. So this is nothing but BC means 4K divided by 5K. When we will cancel K and K together, this would be nothing but 4/5. And in the similar manner, let's just talk about the cos of A. So cos of A is nothing but base by hypotenuse. So base is nothing but AB, hypotenuse is nothing but AC, AB is nothing but 3K, and this is nothing but 5K. K and K get cancelled with each other. This is nothing but 3/5. And now let's just move on further towards the tangent of A. We definitely know the tangent of A, but let us suppose if I'll write it over here, the tangent of A is actually nothing but perpendicular by base, which is already given to us as 4/3. Now let's just talk about the cosec of A. The cosec of A. Cosec of A is actually the reciprocal of sine of A, which is nothing but H by P. So this would be nothing but 5/4. So I'm just taking a reciprocal of this one only. So let's just talk about the sec of A. Sec of A is nothing but the reciprocal of cos of A, and this is nothing but H by B, and we can write it as nothing but 5/3. Now let's just talk about the cot of A. So cot of A is nothing but reciprocal of tan of A. So this is nothing but B by P, and we can resemble it as 3/4. So hence these are all the trigonometric ratios of the angle A. So as you can see, only using one given situation in which we have tangent of A as nothing but 4/3, we have calculated the other trigonometric ratios for the angle of A. So this is all about the example number 1. Now let's just see the next example related to the trigonometric ratios. It says given 15 cot A is equal to 8, find sin A and sec A. So first of all, let's just solve this particular expression. Since it is given to us that 15 cot of A is nothing but is equal to 8, let's just find the value of cot of A. So cot of A would be definitely nothing but 8/15. So this is nothing but 8/15. So let us suppose if I am forming a particular right triangle over here, which is right angled at B, and since we are talking about the angle A, so this is my angle A. Let us suppose if I'm taking this one as B, I'm taking this one as nothing but C. So since we have cot of A, and we know that cot of A is actually nothing but a reciprocal of tan of A, and this actually represents base by perpendicular. This actually represent base by perpendicular ratio. Means base is nothing but 8 and perpendicular is nothing but 15. So since it is in a ratio, so we are taking it as 15k and 8k. This would be nothing but 15k and 8k. So let if BC, since we have the base as nothing but over here as AB and perpendicular over here as nothing but BC. So since let if BC is nothing but is equal to 15k and AB as nothing but is equal to 8k, since they were in the ratio 8/15. So again, using the Pythagoras theorem, we can able to find out the hypotenuse. So using the Pythagoras theorem, we can say that AC's square is equal to AB's square plus BC's square. So this would be nothing but AC's square is equal to 8k whole square plus 15k whole square. So let's just sort it out. AC square is equal to 64k square plus of 225k square, and this would be nothing but AC square is equal to 2 and 6 and 2 is 8, and we have 9k square, and this is definitely 17's whole square. So this is 17k whole square, and after that we are getting the value AC as nothing but 17k. So since the hypotenuse we are getting is nothing but 17k, now further we can able to find out the trigonometric ratio of any particular sine, cos, tan, and further so goes on. So let us suppose if we have to find out sine of A. So sine of A would be nothing but is equal to, we know that sine of A is nothing but perpendicular by hypotenuse. So this is nothing but BC divided by AC, and hence this would be nothing but 15k by 17k. K and K get cancelled with each other. This would be nothing but 15/17. Now let's just talk about the second one. This is nothing but sec of A. So sec of A is actually nothing but the reciprocal of cos of A. And since it is the reciprocal of cos of A, so we can write it as cos of A, and this would be nothing but h by B, and the hypotenuse is AC, base is nothing but AB. So this would be nothing but 17k divided by 8k. K and K get cancelled. This is nothing but 17/8. So this is nothing but the answer for this particular question, that sine of A is nothing but 15/17, sec of A is nothing but 17/8. But let us suppose if I'll just ask you, if there's a question from my side, that I'll ask you, what is sine of C? What is sine of angle C? Let us suppose I just want to find out sine of C. So it means that we are concentrating on the angle C now. It means we are just taking the angle C over here. So let us suppose if I am just recreating this particular figure again. So since we are talking about the angle C, so I'm just taking the angle C on a grounded level like this. Let us suppose if I'm just taking this angle C, this is my angle B, this is the angle A. So this is A, B and C. So let us suppose if I want to write the angle C, let us suppose if I'll write it over here. This is my angle C. Now as you can see, if I'm just taking my angle C in this particular manner, then all the sides will get changed. Means now AB, since in that figure AB was nothing but the base, but now AB is nothing but my perpendicular. Now 15k over here was nothing but the perpendicular. Now this 15k would be my base would be my base, and further the hypotenuse remains the same. So if I just want to find out the different angle, then you can see over here that the perpendicular and the base get interchanged with each other. So now if I just wanted to find out sine of C, so sine of C is nothing but perpendicular by hypotenuse, so the perpendicular over here is nothing but 8k, hypotenuse is 17k, k and k get cancelled with each other, the answer is nothing but 8 by 17. So you can see the difference all by yourself. If the angles will get changed, you will get the different trigonometric ratio. Means sine of A over here is nothing but 15 by 17, but if I am just talking about sine of C, then it is nothing but 8 by 17 because of the difference in between the angles, because here we were taking the angle A, but here we are taking the angle C. So always remember this particular fact, that whenever we are talking about the different angles, then the ratio would be different to each other because the perpendicular and the base will get interchanged with each other. So this is all about the example number 2.